a flask is taken and in that flask there is a mixture of acetone plus water. Acetone and water mixture is taken, which we have to separate. Now, this flask, it has a cork here. It is now heated from here. Heated. This is a mixture of water and acetone. Now, vapors will rise here. And here in this cork, there is a thermometer. This is thermometer. Now, these vapors, they come out from here. And this is a condenser. Condenser means cold water goes in and hot water comes out. Now, these vapors which are getting formed here, this is what? This is all water. Now, you are heating the mixture of acetone and water. Acetone, as I told you, the boiling point of acetone is 56 degree and boiling point of water, it is 100 degree. So, what will happen? First, vapors of which will be formed? Obviously, acetone, because it has low boiling point. So, here you will see that the temperature is 56 degree and all the vapors which are coming out, they are maximum, you can say they are of acetone. And here all these vapors of acetone, from here they will come down and they will come in the condenser. In condenser what is being done? Cold water, it is entered from here and these vapors, as they go down from here, they will get condensed. They will get condensed means they will change from gaseous state to liquid state, and this water will get heated up because of this change. And therefore, now what will come out of this? It will be collected in a beaker, and that will be what? That will be the drops of acetone, liquid acetone. Again, let us revise, children. We have to separate the mixture of two miscible liquids. Miscible liquids means they get mixed up with each other. One is water and the other is acetone. Water has 100 degree temperature boiling point, acetone has 56 degree. What do? We take a flask and in that flask we take the mixture of acetone and water. and there is a cork, and in this cork there is fitted a thermometer. You can see the change in temperature of the thermometer. Now, and here all the vapors which are coming out, this is a condenser. This condenser is attached to the flask. In the condenser, cold water comes from here and hot water goes out. So, when this mixture is heated, vapors of acetone will be formed first. Till the temperature is 56 degree here, all the vapors which are formed, they are of acetone. These vapors, they will rise up and they will go into the condenser, they will get condensed, they will change into liquid, and you will get liquid acetone here. Now, when the temperature rises, it means that all the acetone, it has come out in the beaker, and whatever is left here in the flask, that is what? That is water. If you continue heating, then you take out this, remove this beaker and take another beaker and keep it here. If you continue heating, again what will happen? The temperature in the thermometer will rise, and when it comes to 100 degree, then you will see that vapors of water will come out and they will get condensed, and in this beaker you will get water. In this way, you can separate a mixture of water and acetone, that is two liquids which are miscible with each other, but their boiling point is quite different. Quite different means there is large difference in the boiling point of these two liquids, that is, one is 56 degree and the other is 100 degree. Now, if suppose the boiling point of two liquids, it is not, you can say the difference in the boiling point is not much. Difference in the boiling point of two liquid, it is not much, or you can say they are nearby, then how do we separate? Because if you will heat, then what will happen? Some vapors of the other liquid will also rise up, right? So, in that case, what do we do is that is called as fractional distillation. Next method, it is fractional distillation. Here, in this fractional distillation, what do we do is, fraction means not complete, but in part or in fraction. Distillation done in little part or in little, you can say fraction, that is called as fractional distillation. As I told you that these two liquids, they have quite different difference in the boiling point. If you take the mixture of chloroform, and benzene, there is the difference in the boiling point is 19 degree. Difference in the boiling point of these two, it is 19 degree only, right? So, what is being done here? Instead of direct distillation, what is being done is fractional distillation is done. Fractional distillation means distillation done in fraction, in part, right? Process is almost the same only. The only thing is that fractional distillation column is introduced here. So, here again you take the flask, the same way in that flask you take the mixture of chloroform and benzene. This boiling point of chloroform, it is around, I think, 61 degree, and boiling point of benzene, it is around 80 degree. right? The difference in the boiling point is less. In that case, that is water and acetone, difference was about more than 40 degree. In this case, difference is less. So, what do? We have introduced a fractionating column. Here there is, this is the flask, and in this flask this is the cork, and here there is a fractionating column. What is this fractionating column, children? Try to understand. This is fractionating column. This is the thermometer here. Thermometer. In this fractionating column, what is taken here? Either porcelain or pieces of stone or glass beads. Glass beads are taken, right? Again, the same thing here. In this fractionating column is attached a condenser. This is the condenser. Here cold water is introduced and hot water comes out. This is all water, and here there is a beaker for collection of the one of the component. This is flask. So, distillation is almost the same, only the thing which we have done here is that we have introduced a fractional distillation column. This is called as fractional distillation column. Right? Here, in this fractional distillation column, what do you observe here? Glass beads are there, or pieces of stones are there, or you can take porcelain also, right? What is the use of this glass beads or pieces of porcelain or pieces of stone? Surface area is increased. If suppose you have a chalk, this is a chalk here, this is a chalk here, and the same chalk I have taken in the form of pieces here. Same chalk I have broken down and I have taken it in the form of pieces. So, which will have more of surface area? This will have or this will have? Obviously, this will have. Why? Because here the inner part has also come out. So, here the same thing, that small pieces of stones or glass beads, they are taken for increasing the surface area. What for we are increasing the surface area? Because when we are heating it here, what will happen? Vapors will rise here. These vapors, they will rise here, and vapors will be maximum of what? Maximum they will be of chloroform, but with chloroform some vapors of benzene will also be there. Why? Because their difference in their boiling point is not much, it is very less. So, when you will start heating, some of the vapors of benzene will also be there. So, here all these vapors they will go up. Now, because here surface area is more, these vapors they will try to go up, and it will, because of more of the surface area, some of the vapors they will get condensed and they will go down. Which vapors will go down? That will be a benzene. And which vapor will go up? That will be a chloroform. And all these chloroform vapors, they will come here and they will go into the condenser. Here again in the condenser what is being done? Cold water is introduced from here and it comes out in the form of hot water because of the heat taken by the vapors. Vapors they get condensed, they change into liquid, and here you get the chloroform. Till you get all the chloroform, till that time temperature will remain same in the thermometer. As soon as the temperature rises, you take off this beaker and then you take another beaker, and that will give you all the liquid benzene. So, in this way you can separate the mixture of chloroform and benzene. Chloroform and benzene, the boiling point difference in the boiling point is not much, that is one is 61 degree, one is 80 degree. Here we do the distillation. Distillation is what? Evaporation and condensation. Here you are heating, you are getting vapors, and here you are changing vapors into liquid, that is evaporation and condensation, evaporation, condensation. But this is fractional distillation. Fractional distillation means not complete but in fraction, it is done in part or in fraction. So, for this a fractionating column is introduced, and in that fractionating column what is there? Pieces of stone or glass beads or porcelain, it is taken. What is the use of this? It increases the surface area, and because of this increase in the surface area, what happens? The vapors as they rise up, they get more surface area, so they get cooled and they get condensed and they come down. Only the vapors of that liquid which has lower boiling point, it rises up and then they go into the condenser and they get liquefied, and we get the separate component. Components are separated by this method. So, this is all about fractional distillation. Then, what is the practical application of this fractional distillation, children? What is the practical application of this? You can separate the different components of petroleum. What is petroleum? It is a crude oil. Crude oil means it is impure oil. It is not pure, it is a mixture of many different components are present. Petroleum, it is the crude oil which is taken out from the earth crust. This boring or digging is done, and from there is under the seabeds there are raised rocks, and in these rocks boring is done, and from the bottom of these rocks what is taken out? Petroleum. and that petroleum, it is a crude oil or it is impure oil or it is a mixture of many different components are there. These different components, they are being separated by this fractional distillation. This is one of the practical application. Then another practical application is separation of the components of air. Different components of air, they are separated by the method of, by the way of fractional distillation. That is components of air. What are the components of air? Major component of air is nitrogen, then oxygen, then some carbon dioxide is also there, then some inert gases are also there. Inert gases are what? Krypton, xenon, neon, argon, all these are inert gases or noble gases or inactive gases, right. So, components of air, they are being separated by fractional distillation method. And what are the components of air? They are nitrogen, oxygen, carbon, inert gases, right. Now, what is being done here? Let us first draw the flow diagram to separate components of air by a fractional distillation method. Now, components of air, as I told you, nitrogen, oxygen, carbon dioxide, inert gases, and these inert gases are krypton, xenon, neon, argon also, right. So, what is being done here? First, this is a filter. Air is taken and first it is filtered. Now, this filtered air, it is being introduced in a compressor. This is a compressor, and here this air, it is introduced into it. Now, this air which is compressed, this is compressed air. This compressed air, it is introduced in a condenser. It is now cooled. Here, cold water goes in and hot water comes out. This compressed air, it comes in this, and this is a condenser. Condenser means here the compressed air, it will get cooled, and this compressed and cooled air, it is then passed into a separator. This is a separator. This is solid carbon dioxide, or you can say dry ice. Now, this air which is compressed and cooled, it is introduced into an expansion jet. It is introduced into an expansion jet. This is expansion jet. Now, from here, the air, it goes into a fractionating column. A fractionating column. Here, in this fractionating column, you will see that the different fractions of air, they get separated right. So, this is the flow diagram or flow chart to separate the components of air. Components of air are, children, nitrogen, oxygen, carbon dioxide, inert gases, and inert gases are krypton, xenon, neon, argon, all, right. So, this air, it is first passed through the filter, so that the dust particles, they are being separated, or you can say filtered. Now, this filtered air, it is introduced into a compressor. This is a compressor. It is first introduced in a compressor, and then this compressed air, it is introduced into a condenser. This is condenser. What for we are doing this? Because we know that this carbon dioxide gas, if it is compressed and if it is cooled, means pressure is increased and temperature is decreased. Then what happens to this carbon dioxide gas? It gets solidified, and when it gets solidified, you can separate it in the form of solid carbon dioxide, or it is also called a dry ice. So, first the air, it is compressed. This compressed air, it is introduced into the condenser. In the condenser, cold water comes from this pipe and comes out what? That is hot water. Why? Because the air which we are introducing here, that will get cooled up. So, this cooled and compressed air, it goes into the separator here, and in this separator solid carbon dioxide is separated. How this solid carbon dioxide is formed? By compressing and by condensing. By increasing the pressure, by decreasing the temperature, you get solid carbon dioxide or dry ice. Now, what is left in the, so this carbon dioxide, it is separated. Now, we have mixture of nitrogen, oxygen and inert gases. Now, this air which is coming out of the separator, it is compressed and cooled. So, what is being done? First, it is introduced into the expansion jet. In the expansion jet, that air gets expands, and here then it is introduced into the fractional distillation column. Fractional distillation column means the air, different fraction or different part of air, they will get separated in different fractions. Now, oxygen, they will get separated according to their boiling point. Here on the uppermost part will come out nitrogen, then inert gases, and from here you will get oxygen in the form of liquid oxygen. So, in this way you can separate the different different components of air by fractional distillation method. So, this is all for today, children. Then we will do in the next class.